All right, so this video will focus on 3.4. And the first thing I want you to do before we get too far along is look at this first slide, and it says, are these triangles similar? Or they're saying they are similar. And it's saying find the value for x. So if I look here, I know that this is a 10 by 4. And I know that this is a 5, and figure out what this x is equal to. So press pause, and then try to solve it, and then press play. All right, so this one is 2. This one here, I have to look for corresponding sides. Now I have my hypotenuse, which in this case is going to be the longest side. I look here for the longest side, it's right here. So that's 12. This right here is x. This shorter side is 12, which corresponds to this shorter side. So you have to set this one up as x over 12 equals 9 over 12. And of course, you could do this doing the means and extreme property. So I would multiply it. I have 144 equals 9x. So divide by 9, divide by 9. And x equals, let's just look here, 16. And there we go. The whole idea today is how can you use angles to tell whether triangles are similar or not. So here's another example where I have this boy and the flagpole. We have the sun's ray coming down, it's like the shadow. These are cool problems, I like these. So what I want you to do first is take a look at this and look for my similar triangles. I have my one angle here, so this is a 5 for the height and a 3 for the shadow that goes away from the boy. And then at my flagpole, I have no idea what the height is of the flagpole, but I do know it's a 30-foot shadow here. Now just looking between these two, what's the scale factor to go from this smaller triangle over to this longer triangle? Hopefully you see that it's times 10. The way you could always figure this out is you could take the 30 divided by 3, and so it's getting bigger. That's why there's two fractions. You either have 30 over 3 or 3 over 30. And if I multiply a number by this, if I multiply it by this one, it'll get bigger. And if I multiply it by this one, it'll get smaller. So I'm trying to solve for the x, which means it's getting larger, right? So I take the value that corresponds, the 5, times the scale factor of 30 over 3, or in this case, 10. So 5 times 10 equals 50. So the height of this flagpole should be 50. Next one says make a triangle that is larger or smaller than the ones given and has the same angle measures, and find the ratio to the corresponding side lengths. All right, so this one here, the key idea essentially is looking at the different triangles and looking for the same angle measurements. And triangle DEF is similar, that's what this little squiggly line means, to DEF, or to ABC, I'm sorry. And the reason why they're similar isn't because they're exactly the same, they'd be congruent. But look at the angle measurements here. This is 95, this is 95. This is 65, this is 65, and then finally 20 and 20. So as long as the angle measurements are the same, it will be similar. So let's look here. I have a 75, a 50, and an x. I have a 75, a 50, and a y. So these are absolutely similar because altogether they have to add up to 180 degrees. Two of them add up to the same amount, right? So therefore the third one's got to be the same. This one here is 54 plus 63. Now this I have 63 and 63. The only way that I could solve this is to take 180. The very first thing is it says tell whether these triangles are similar. If I look here, this is 75 and 50. Let's just add that up. 75 plus 50, and I get 125. That means that if I have that and I want to make it so I find my last angle, I'll have negative 125 plus 180. And I get 55. So this has got to be 55. I can then look at here, and I notice that I have two of the same angles. If you have two of the same angles, the third one has to be the same if it adds up to 180. So this one is absolutely similar. This one here, if I take 54 plus 63, I get 117. So if I take that and I subtract it, so let's go to the negative side, say plus 180, I get 63. So this has to be a 63 as well, which means that if I have 63 plus 63, this must be 54. So these are also similar. Here I have my 90 and my 90, but the difference is the 42 and the 38, so we have to figure out the last side. So let's go through and take 90 plus 42, and I will subtract that from 180. So plus 180. And I get 48, and this is 38. So since this is going to be a different number than this one, unfortunately this will not be similar. But this one is not. So now we'll do the same kind of thing here and figure out if they are the same or not. We know we have 28x and 80. So this is 108. 108 plus this right here is 109, unfortunately. Or I'm sorry, this is 99. So I don't believe it will work for this one. This one here, if I look at it, I have my 60 plus 90 and x. And this is 24, y, and x. This is, because both triangles will have the same measurements, 66, 90, and 24. This one here is I'm planning to cross a river. I want to know how far it is across. This is a really easy mistake to make. So I have my 60 over my 50. And I don't know if you noticed, but I looked at it and I thought this has got to be wrong since it should correspond to my longer side. So the 40 is going to correspond to my shorter side. So if I look here, I'm going to have 50x equals 2400. And now divide by 50, and x has got to equal, I go through here, 2400. I get 48. So this should be 48 here. And there we go. So the last question I have for you are these similar, yes or no? And in order to figure it out, you got to first figure out what this equals and then take that away from 180. So let's just do that. Let's take 94 plus 48 equals 142, and I'm going to subtract that or add plus 180. Try that again. 94 plus 48 equals, and then do the negative version of that, plus 180. And I get 38. So it will in fact work. Since I have a 94, 38, and 48, it will absolutely work.